my god, I just can't solve this physics problem. I just can't visualize it in my head.
It's okay. What's the problem?
Well, it's a projectile motion problem where a ball is thrown.
Okay, let's get started. Using the exact velocity or angle of elevation. Okay, so to repeat the question, a ball is thrown with the initial velocity of 36 meters per second and an angle of elevation of 25 degrees. So first we're looking for what the max height of the projectile is. So here's a diagram. Okay, so here's the diagram. So we have the ball with an initial velocity of 36 meters per second, and this is the max height that we're looking for. So we need to look for the velocity initial in the y direction. Looking at this diagram, we can solve for velocity in the y direction by using our trig ratios. So we can use v initial sine theta equals v initial in the y direction, which is 36 sine 25 equals v initial in the y direction, which is 15.214. So here we have our v initial being 15.214 meters per second and our v final being 0 meters per second because it'll go to the top and then it'll stop momentarily and then start falling, making it 0. So the kinematic equation we can use to solve for delta y is delta y equals v initial times delta t plus 1/2 times acceleration times delta t squared. So what we don't have is our delta t and our acceleration, so we need to solve for these. So first we're going to solve for acceleration. So the only force that's acting on the ball after it's thrown is gravity. So we can write force equals mass times gravity. And force equals mass times acceleration, so masses will cancel out and we'll have acceleration equals gravity. Gravity equals negative 9.8, so that means acceleration is negative 9.8. So now we're solving for time. The kinematic equation we can use for this is velocity final minus velocity initial equals acceleration times delta t. So 0 minus 15.214 equals negative 9.8 times delta t. Rearranging, we can solve for delta t as equals negative 15.214 divided by negative 9.8, giving us a delta t of 1.55 seconds. So it takes 1.55 seconds for us to reach a max height. Plugging in all of our values, which I have written here, we can solve for delta y equals 15.214 meters per second times 1.55 seconds plus 1/2 times negative 9.8 times 1.55 squared. Everything will cancel out, leaving us with meters. So delta y is 11.8. So rounding to 2 sig digs, we round that to 12 meters. So therefore, the ball reaches a max height of 12 meters.
So for part B, we're finding the total time the ball was in the air. So as found the time that the ball reaches its maximum height from part A, we found it right here. So the ball will reach its maximum height at 1.55 seconds. So the total time is the time it takes for the ball to go up to the max height and then for the ball to come down. So when we add those two, it will give us the total time. So the total time of the ball going up and going down is the same. So the total time is t times 2 times t. So as we found a t over here, we're going to plug it in and we will multiply it by 2 and the total time we will get is 3.10 seconds. Okay, so for part C, we're finding the horizontal position at t equals 2 seconds. So we will be using our triangle, the trig ratios. So as we did in part A, we found the initial vertical velocity. So in part C, we're finding the horizontal initial velocity. So using the trig ratios, we're going to solve for the horizontal velocity to solve for the horizontal position. So here I have the equation. So cos theta equals horizontal velocity divided by the velocity, which is 36. And so from our kinematic equation, we know that the acceleration is 0 in the horizontal direction. So that's why I have A equals 0. And so then we're just left with velocity in the x direction times time times the time. And so that's why when we solve for this, the velocity is 32.6 meters per second. And then we just multiply by the time that was given in the equation, which gives us 62.25 meters. By using significant digits, which is only 2, it's 62 meters.